In this lesson, you will learn how firewalls were created to provide rudimentary network security and how they've evolved to keep up with the ever-changing threat landscape. As networks first began to grow and become interconnected with each other and eventually connected to the Internet, it became important to control the flow of network traffic. This control initially took the form of packet filter firewalls, which act by examining the very lowest protocol layers, such as the source and destination network addresses, the protocol, and port numbers. A set of rules in the firewall used these attributes to define which packets would be allowed through. If the packet's network addresses, protocol, and port number match those of a packet filtering rule in the firewall, it would be allowed to pass through. If it didn't, it would either be silently dropped or blocked with a special message being sent back to the sender, indicating that their traffic was blocked. In general, these early packet filter firewalls were very simple and blocked all traffic by default, except for packets that matched one or more rules. Packet filter firewalls worked as planned, but they had a few drawbacks. Primarily, they took a bit of a one-size-fits-all or sledgehammer approach to deciding whether or not to allow traffic to pass. For example, other criteria may be important in the decision to block or allow traffic of a higher-level protocol such as HTTP or FTP. One such criteria could be the behavior of the connection itself. Bad actors were known to exploit bugs in a computer's networking software by making a connection behave in unexpected ways, or they would try to inject rogue packets through the firewall that don't belong to any existing connection. The second generation of firewalls were designed to add more functionality by observing these network connections over time. These second-generation firewalls were also known as stateful firewalls because they would watch as new network connections were being made and then continuously examine the conversation between the endpoints. If a connection behaved improperly, then the firewall would block that connection, and any packets not belonging to a known conversation were dropped. While this was a step forward, it didn't solve the one-size-fits-all nature of how the firewall rules worked, and the explosion in the use of the World Wide Web caused a shift in the composition of network protocols in use to be heavily skewed towards HTTP. Now the problem is that HTTP can be used in many ways, such as static text content, e-commerce, file hosting, and many more different kinds of web applications. And since they all use the same port number, the firewall is not able to distinguish between them. Network administrators need to distinguish between these web applications in order to block the malicious ones and allow the beneficial ones. To be able to see how protocols such as HTTP are being used, the firewall must look deeper into the data payloads. The third generation of firewalls do just that. By understanding the higher-level protocols and the applications inside them, the third-generation firewalls can control different uses of the same basic protocol. This is known as application layer filtering, and firewalls that implement application layer filtering can understand protocols such as HTTP, FTP, DNS, and others. And in the case of HTTP, it can differentiate between browser traffic to a blog, a file-sharing site, e-commerce, social media, voice over IP, email, and many more. Along with firewalls, most networks rely on a set of services to function properly or to provide different types of network security functions. Examples of this include DHCP, Virtual Private Networking or VPN, Intrusion Prevention Systems or IPS, web filtering, application control, antivirus, anti-spam, and endpoint control. Since each of these technologies were developed independently, it was not uncommon that separate, standalone products were purchased for each function. And it wasn't long until the number of network appliances became a problem itself. To address this problem, many vendors incorporated these functions in their application filter firewall products designed for small to medium-sized networks and called the result Unified Threat Management, or UTM for short. UTM products drastically simplify the installation and ongoing management of these small to medium-sized networks. The trend of incorporating these additional network services into a single firewall product extends into the larger enterprise networks as well. These large, high-performance firewall products tend to go deeper into the protocols and applications to allow even finer-grained control needed to meet the needs of enterprise networks. In addition to most of the UTM services, these enterprise firewall products can also include extended IPS, Web Application Firewall, or WAF, and some form of user identity management, which ties the traffic flowing through the firewall with individual users. These firewalls are known as next-generation firewalls. Fortinet's line of firewall products is named FortiGate and are designed to scale from small networks to the largest enterprise networks, diverse cloud deployments, carrier-grade networks, and complex environments deployed by managed service providers. FortiGate firewalls and FortiGuard Labs threat intelligence services work tightly together to provide the highest level of network security. Thank you for your time, and please remember to take the quiz that follows this lesson.